Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. Now, first we check how to get the Unacademy learning app into your device. If this app is already in your device, it's okay. Otherwise, install it. Just go to Play Store in your device. Type Unacademy in that. Then you will get the Unacademy learning app like this. In this, here there is a install button. Just click on this install button, then it will install the Unacademy learning app into your device. Okay, now after installing that, just open that app in your device. By opening that app into your device, it will shows what are the different courses available in Unacademy, and in each course we have generally different subjects, and each subject handled by who are the top educators handling that subject. You get that information. Okay, now here I am going to introducing a few of the top educators who are working under Unacademy. See, Marut Tiwari sir, so he is the IIT topper. And Ankit Goyal sir, he obtained 2 times All India first rank in GATE examination, electrical department, and he was awarded President of India gold medal in IIT Indore. He teaches the subjects for electrical and electronic students. And there is Sanchit Jain sir, he is the top faculty in computer science. And Jaspal Singh sir is the ex-IAS officer. He got All India 4th rank in IAS. Okay, he is the scientist. GATE, state service examinations, everything, what not. In all my examinations, he is the topper. Okay, and he's the ex-senior Made Easy faculty. He has more than 16 years of teaching experience. Okay, now here are few more faculty, top faculty working under Unacademy. Okay, now we are happy to announce that recently we started a new batches for GATE 2022 and 2023. There is a Ascend batch for GATE 2023 for mechanical engineering. This batch started from 22nd February 2021, and during subscription use my code VRAU10 to get 10% discount. Okay, here are the top faculty who are handling the subjects under this, and the same faculty are going to handling the GATE 2022 batch also. This is the Evolve batch. This batch started from 22nd February 2021. Okay, sorry. Next, there is a Spark batch for GATE 2022 civil engineering. This is English batch. Okay, and here are the top faculty who are handling the subjects in this: Krishna Prakash, Rajendra Prasad, Praveen Kulkarni sir. These are the top faculty. This batch started from 22nd February 2021. Okay. Next, there is a mission DDR. So this is specially for mechanical department students. This is for mechanical students, mechanical department. Okay. This batch started from 22nd February 2021. This is the new batch, and here are the top faculty who are working under this. Tiwari sir, already I told about him. He is the IIT topper. K. Maheshwar Rao sir, South side, he is the one of the top faculty in mechanical engineering, famous faculty. Meenu Gupta ma'am and Aman Rao sir, they are also top faculties. Okay, they are the top educators. Already they success in their examinations. Already they crossed that path. Okay, and they know what are the hurdles in that, how to prepare, which topics we need to stress more. Okay, after completion of the examination, what we need to verify. Okay, In your preparation, there is any gaps, they will fulfill those gaps. So that is the mission DDR batch. And during subscription, please use my code VRAW10 to get the 10% discount. Next, there is Ascent batch for GATE 2023 for civil engineering. This batch started from 8th February 2021. Here are the top faculty who are working under this batch: Jaspal Singh sir, JS Gill sir, Chagi sir. Okay, and here are the few more faculty. And there is the same civil engineering GATE 2022 eval batch. This batch started from 8th February 2021. Okay, don't forget to use my code VRAW10 during subscription. Okay, by using this code you get 10% discount. Next, there is an eval batch for GATE 2022 for computer science and information technology. There is a famous Ravindra Babu sir is there, and Sanchit Jain sir, Subbarao sir. Here are the top faculty: Mallesham sir, Vishwadeep, Shweta Kumari ma'am. Here are the top educators, and already they proved what they are. Okay, so with that faculty we started a new batch for computer science and information technology. Now this batch started from 8th February 2021. Now we move to electrical engineering department. In electrical engineering, there is a Ascend batch for GATE 2023 electrical department. Here are the top faculty who are working under that. In general, electrical department, more number of subjects is there. That's why here we are introducing more number of faculty. Okay, and this batch started from 1st February 2021. And there is Ascend batch for GATE 2023 electronics and communication engineering this time. Here are the top faculty who are handling the subjects in this batch. This batch started from 1st February 2021. Don't forget to use my code VRAW10 during subscription. By using this code you get 10% discount. Next, there is a eval batch for GATE 2022 for electrical engineering. This batch started from 1st February 2021. Here are the top faculty who are working under this. Okay, and for same faculty, for GATE 2023, who are the faculty handle the subjects? For GATE 2022 also the same faculty are handling the subjects. This batch started from 1st February. And there is a eval batch for GATE 2022. This time this is for electronics and communication engineering. Okay, now this batch started from 1st February 2021. Next, there is a chemical engineering. So there is a eval batch for GATE 2022 for chemical engineering. This batch started from 25th January 2021. So, and my dear friends, if any of your friends and colleagues, anyone else doing chemical engineering, please inform this one to them. Throughout India, hardly 1 or 2 locations only training for GATE examination for chemical engineering is available. But now for the people who are studying at other places and doing jobs at other locations, for them it is very difficult to move that location and attending the classes. In that aspect, we started this new batch for chemical engineering. Top educators who are in chemical engineering, we gathered those people, and now they are going to training the people in chemical engineering. Okay, so here are the faculty in that: Bansal sir, Shailendra Kumar, Devendra sir, Prajapati, Manish sir. So here are the top faculty in chemical engineering. And yeah, now see the students who are studying the third year, second year, third year and final year, there is a golden opportunity to you. That is Unacademy Comeback. See here, this is the India's biggest free scholarship test for GATE and service examinations, engineering service examinations. Here you are going to getting 85 lakhs plus worth of scholarship you are going to getting it. Okay. So there is a examination 28th February 2021 at 11 a.m. Okay. So there is a scholarship test. Just attempt that test, then there is a chance of getting more benefits to you. And just use my code VRAU10 during subscription, during enrollment. During enrollment, use my code VRAU10 during scholarship. Use my code VRAU10 during enrolling. Okay, and write the examination on 11th a.m. on coming Sunday, 28th February, and you get the more benefits by attending this. See, what are the benefits you are going to be getting here? See, if you get the 1 to 3rd rank, first to 3rd rank, if you get complete complimentary Unacademy Plus subscription for the tenure of 4 years. For the tenure of 4 years, you get that. Okay. And if your rank is 4 to 10 in between, 75% of Unacademy Plus subscription for the tenure of your choice. See, tenure here of your choice means you can take the course for, you can join the course for either 12 months, 18 months or 24 months as you wish. 75% of plus subscription we are going to providing free as a scholarship. Okay, you need to pay only 25%. If your rank is in between 1 to 3, you need to pay only 0, no need to pay anything. If your rank is between 4 to 10 for plus subscription, you need to pay only 25% of the amount. Okay, if your rank is between 11 to 50, you need to pay only 50%. 50% scholarship you get. Okay, now tenure you can choice is yours. Either you can take 12 months, 18 months or 24 months. Choice is yours. Okay, and if your rank is 51 to 100 rank, so you get 25% of discount. Okay, 25% discount. Is it okay? Now, so my dear students, don't make delay, make it fast, make enrollments. Okay, write the exam on scholarship exam on coming Sunday at 11 a.m. Write the exam, get the more scholarships and get more benefits. Okay, and just a glance, we go on check what are the different engineering disciplines available in an academy. Mechanical engineering, electrical engineering, electronics and communication engineering, computer science and IT department, civil engineering. Okay, now instrumentation, production and industrial, chemical engineering. See, not only single, every department is available here. So my dear students, please don't waste your time. Okay, join the class, enjoy the subject. Okay, and your classes are going to be here mainly handled by India's top educators. Okay, please keep it in your mind. So India's top educators are going to handling your classes. Sorry for delay. So these are the different disciplines available here. And now, see, Here we have two plans. Plus plan and iconic plan. In plus plan is the basic plan. Plus plan is the basic plan. In this plan, you get India's best educators are going to handle your classes. Interactive live classes are there. Structured courses and PDFs are available. Live tests and quizzes are available. Live tests and quizzes are available. And iconic plan. This iconic plan take your GATE and service examination, engineering service examination preparation to a next level. It will take your preparation to next level by providing personal coach to you. By providing a personal coach to you. So please, my dear students, please take a note of this. Here we are providing personal coach. Personal coach. You may ask one thing, sorry, we are not playing any cricket to provide a coach. See, life is a game, but study is also a game. You do a small mistake, you lose marks. You lose the marks. Here, the purpose of main personal coach is he plays a vital role here. See, I will explain that. If you compare the people who are success in their examinations and who are not success up to that level, if you compare, there is a clear difference. One clear difference is there. That is, after completion of the examination, the people who are analyzed their examination paper and they take a note of where they are strong, where they are doing mistakes, and where they need preparation. Okay, and if they identify the gaps in their preparation, okay, then they are going to success in their career. Okay, now at present the students who are studying third year and final year, they are very busy with their academics. They don't have much time. Okay, to analyze each paper, minimum 2 hours is required. Not 10 minutes, 15 minutes, not that like that. Minimum 2 hours is required to analyze the examination paper what you've written. So before going to attending the exam, you need to attempt subject-wise tests and topic-wise test in every subject. Subject-wise tests, whole exam. That means by combining all the subjects, single tests. So multiple examinations you need to write. In these examinations, in these multiple examinations, we need to identify. We are going to identify where the student is strong, where the student required more preparation, in which topic he need more coaching, more training. Okay, where student is committing mistake. So that means we are going to identify the gaps in your preparation. By identifying those gaps, we try to fulfill those gaps with proper study planner. We are providing a proper study planner to you. After that, proper study material we will provide. By providing these two, we will fulfill the gaps in the students' preparation for their GATE examination. Okay, finally we make the student fully strength with a full of confidence. We will send the student to write the examination. Now the student should be like a loaded gun. Okay, so my dear students, please think once of it. So there are more benefits here, and if you observe the cost of each and every plan, there is not much deviation. There is a plus plan. In this you have 1 month subscription, 3 month subscription, 6 month subscription, 1 year subscription, and 1.5 year subscription, 2 year subscriptions. As a faculty, I recommend the students take minimum of 1 year subscription. So minimum 1 year is required. Minimum 1 year is required to prepare all the subjects, to understand the concepts thoroughly, to write sufficient number of examinations in that topic wise, subject wise, and as a whole. Okay, and to identify the gaps in your preparation, to fulfill those gaps, you need minimum 1 year. Okay, so my dear students, and one more thing here, by using my code VRAO10 during subscription, you get 10% discount. Okay, after discount, its cost is only 27,225 rupees. Okay, now we move to next iconic plan. In iconic plan, only two subscriptions, 12 month subscription and 2 months 24 month subscription, 1 year subscription and 2 year subscriptions. Okay, for 1 year it is 50,250 rupees. By using my code VRAO10 during subscription, it became 45,225 rupees only. Okay, now here we are providing personal coach to you, because that personal coach we are charging this much. Don't forget to use my code VRAO10 during subscription to get 10% discount. Thank you. Thanks for spending your time. Now we are moving to our content. So our today's topic is a transistor. It's a construction and operation. This session we go to, it's a construction definition and a construction. Next session we go to operation. Okay, just a minute. Okay, now now we are going to first transistor. What is transistor? Before going to transistor, there are two dominant features we observed in PN junction diode. Here I am going to taking the PN junction diode. If you take the PN junction diode, let us take a PN junction diode. So this is a PN junction diode. This is P region and this is N region. You can operate this in two ways: forward bias and reverse bias. In forward bias, P connected to positive, N connected to negative. In reverse bias, P connected to negative terminal of the battery and N connected to positive terminal of the battery. Okay. In forward bias, what we observed is, injection of minority charge, diffusion of minority charge carriers in this region. In P region, diffusion of electrons takes place. In N region, diffusion of holes takes place. So, diffusion of minority charge carriers. Diffusion of minority charge carriers. Diffusion of minority charge carriers. Minority carriers. In reverse bias, variation of depletion region. Variation of depletion region. In reverse bias, by increasing applied reverse voltage, depletion region width is increasing. In forward bias, once your diode is under forward bias, now holes are injected into N region and they are diffused in N region. Electrons are injected into P region and they diffuse in the N region like this. They diffuse like this. Okay. These are the two dominant features takes place in a PN junction diode. Now, these two features simultaneously we can get in a transistor. Diffusion of minority charge carriers as well as variation of depletion region. We can observe both the things in a transistor. Okay. Basically, how can we define a transistor? This is very, very important. So most of the students are unable to understand what is the transistor. So my dear students, better to take a notes if possible. Transistor. Basically, transistor is a current device. First point is, transistor is a current device. Transistor is a current device. Transistor is a current device. What is the meaning of current device? What we understand from this? What is the meaning of current device? It means at output it provides current to you. At output it provides current. That is the meaning of current device. At output it provides current to you. Okay. So current device means it provides current. That is the meaning of current device. Now, this current should be under your control. This current should be under your control. That is the important thing. Okay. Now, how can we control this current? That is the important thing. I control this current from input side. By applying something at input side, I control this current. Here, from input side, by applying either input current we can control this, or by applying input voltage also we can control this. Okay, so now your output current is controlled by input current, or it can also be controlled by input voltage. That means from input side I am going to controlling the output current. From input I am applying two parameters. Either input current you can use, or either input voltage you can use to control the output current. For example, I am using input current. Then we call it as current controlled current device. Or in this case, if input voltage is going to control the output current, then we called voltage controlled current device. Voltage controlled current device. Okay. At input side, if your input current is controlling output current, then we called it current controlled current device. If your input voltage is going to controlling output current, then we called it voltage controlled current device. And here the example for current controlled current device is BJT, bipolar junction transistor. BJT is the current controlled current device and FET is the voltage controlled current device. controlled current device is FET. FET is the voltage controlled current device. And another one we have, that is a voltage controlled voltage device, that is op amp, operational amplifier. Op amp, operational amplifier. So the meaning of op amp is whatever the mathematical operations we have, addition, subtraction, multiplication, division, square root, integration, differentiation, what not, whatever the mathematical operations we have, we can perform all mathematical operations by using the op amp. You may ask one thing, sir, we have calci, we can do those calculations by using our calci. You can do that. You can do addition by using your calci for 2 plus 3. You can do. But what about x of t plus y of t? Two signals I am applying. Two signals I am giving to you. You need to add those two signals. You need to multiply two signals. You need to divide two signals. You need to integrate a signal. You need to differentiate a signal. Then how can you perform those things? So you can perform all those things simply by using operational amplifier. Because of that only we call it as an operational amplifier. Op amp simply we called it. It is the voltage controlled voltage device, and BJT is current controlled current device. FET is voltage controlled current device. Now you observed or not, in these two cases both are current devices. Okay, so when you are going to understand studying in detail about transistor, transistor means both BJT and FET, both are comes under transistor. But in general terminology, transistor means we are using only, for BJT we are using transistor the term, for FET we are using FET itself, FET or MOSFET. For JFET we use the term FET, for MOSFET we use general term MOS or MOS device or MOSFET. Okay, now how can you say BJT is a current controlled current device? Is there any supporting equation? Similarly for this, is there any supporting equation? Now sir, for about this one later we discuss about this, but here our intention is to study about these two transistors. Now first I am taking the BJT. So BJT is, BJT, bipolar junction transistor. Just before you mentioned it is a current controlled current device, CCCD, current controlled current device. The supporting equation is IC is beta times IB plus 1 plus beta times IC naught. Here you observe one thing, beta is the constant for a given transistor. This is the CE current gain. Beta is CE current gain. It is constant. IC naught, reverse saturation collector junction current. It is also constant. This is the base current. It is the input current. Input current. This is the IC. This is output current. Output current. See this? Here output current is going to be controlled by input current. By varying the base current, collector current is varying. If it is low, it became low. If it is high, it is also high. That is the controlling mechanism. How it is controlling, actually, we discuss about that one in detail during the operation of BJT. Okay, next one is, now I am going to FET. See, for FET, so we are saying FET is a voltage controlled current device. Voltage controlled current device. Voltage controlled current device. The supporting equation for this one is ID equals to IDSS into 1 minus VGS by VP whole square. In this, this is the output current. Output current. This is the maximum drain current. This is the constant for a given device. VP is the pinch off voltage. It is also constant for a given device. And the remaining is VGS. VGS is the input voltage. This is the input voltage. Input voltage. Okay. Input voltage. Input voltage. Now, here, if VGS value is changing, ID value is going to change. So output current is controlled by input voltage. And sometimes we call it IDS, drain to source current. Okay. These are the supporting equations for VCCD and CCCD, BJT and FET. Anyway, both are current devices. That is very important thing. Current device means at output it provides current to you. Now that current should be controllable. To control that output current, I am going to using either input current or input voltage. If you are using input current to control that output current, we called it current controlled current device, that is BJT. Now I am going to concentrating completely on BJT. BJT. So BJT means bipolar junction transistor. Bipolar junction transistor. Bipolar means, bi means two, we know that. Bipolar means in BJT current is due to both the type of charge carriers, electrons and holes. Current is due to both the type of charge carriers, electrons and holes. That is the meaning of bipolar here. And it has two junctions. It has two junctions and three terminals. Three terminals. It has two junctions and three terminals. That is BJT. And we have two types of BJTs. Two types. They are NPN transistor and PNP transistor. NPN transistor and PNP transistor. NPN and PNP transistor. Okay, these are the two types of transistors. Default transistor is NPN transistor. So most of the students you are using in your lab NPN transistor, because mobility of electrons is high compared to mobility of holes. Because of that, we are giving high priority to NPN transistors. Now you may ask, what is mobility? Already we discussed about that mobility in semiconductors. There is a simple comparison I will told between the for a mobility of electrons and holes. See, you can compare mobility of holes with tube light. Okay, you can compare mobility of electrons with a regular light, 60 candles bulb. Okay, once we switch on, tube light takes little bit more time compared to regular 60 candles bulb. 60 candles bulb, immediately once you switch on, immediately it will glow. Immediately it will glow. Now, but in case of this PNP trans, in case of holes, tube light, it is first 2 to 3 times on off, glow off, glow off, glow off, later finally glow. Okay, takes little bit time. That is the difference. So in your labs you are going to using NPN transistor. Okay, NPN transistor. But here, for better understanding of the transistor, we are going to using PNP transistor. Why? Because in NPN transistor, majority of the current is due to electrons, but current direction is opposite to the direction of movement of electrons. Here there is a chance of making mistake in changing the directions. Okay, in selecting the proper direction. Because of that reason only, we are going to using PNP transistor for better understanding of transistor. Okay, and in practically in most of the circuits also we are using NPN transistors. In maximum exams also they provide NPN transistor. Rare conditions they use PNP. Okay, but a slight difference for using NPN and PNP. Okay, here we are going to solving problems on both NPN and PNP transistors for practice purpose. Okay, now first I'm going to constructing the transistor. Later we go and discuss about its operation. Now first one is construction. Now first I am going to construction. How to construct the transistor. Okay, now this is the construction. So these are the 3 terminals and 3 regions transistor. This is emitter, we called it by E, emitter. This is base, this is collector. collector. Emitter, base and collector. Now here I am taking PNP transistor. So that means it is the p-type semiconductor. This region is p-type semiconductor and it is also a p-type and it is n-type semiconductor. If you want to say strictly, this is going to be p plus, and it is n minus, and it is p as usual. Now you may ask one thing, what is the meaning of p plus and n minus? Why are you adding plus to that? Why are you adding in negative to n? The meaning of p plus is that semiconductor emitter region is doped heavily. Emitter region is doped heavily. That is the meaning of p plus. Okay. Next, n minus. What is the meaning of n minus? That is lightly doped. Lightly doped. And here you have p. P means it is moderately doped. It is moderately doped. For example, I want to take a chai. Generally, once we taking the chai at outside, you observe different persons ask different taste. Someone ask light tea. Someone ask strong tea. So strong tea in the sense they will add the milk content in that one is less. Okay. Next, light tea. Light tea means milk content is more in that. Next one is normal tea. So milk content is a normal level. So in terms of sugar, if you considered, someone take more sugar, someone take with light sugar, someone take with normal sugar. So light sugar is base region, high sugar, more sugar is emitter region. Okay. More average level of, that means normal level of sugar is collector region. So the important point you need to consider here is emitter is doped heavily, base is doped lightly, and collector is doped moderately. This is the very important point you need to consider here. Okay. Now later we get what is the reason to take emitter is doped heavily, base doped lightly, collector doped moderately. Okay, there is a reason for everything. Next we get that. Okay. Now, and after that, you observed or not, this is the physical width, this is the width of the base region. Width of the base region is, sorry, emitter is WE and width of the collector is WC, and automatically width of the emitter base is WB. The base is the width of the base, that means the base is narrow width and emitter width is moderate, collector width is large in size. Collector width is large in size. Okay. Now, here, first we check, we take each and every terminal, the purpose of the use of each and every terminal. For achieving that thing, we are going to be placing its physical parameters and doping like that. First, I am going to taking one by one. So first one is I am taking emitter. See, the function of emitter is, the name itself shows, it has to emit large number of majority charge carriers. The function of emitter is it has to emit large number of majority charge carriers. Now I am writing that. First point in emitter is its function is to emit large number of majority charge carriers. Its function is to emit large number of majority charge carriers. Now, just understand this properly, sir. To emit a large number of majority charge carriers. To emit a large number of majority carriers, first it has to maintain large number of majority charge carriers. So high number of majority charge carriers it has to maintain. Once it maintains large number of majority charge carriers, then only it will emit large number of majority charge carriers. Is it clear? If I have more money, then only I can give money to you. If I don't have money, how can I give that money to you? Yes or no? Same thing. First, emitter has to maintain large number of majority charge carriers. Then only it can emit large number of majority charge carriers. Now, in semiconductors, we observed to increase the majority charge carriers, amount of doping has to be increased. And to increase minority charge carriers, amount of temperature has to be increased. So here I want more number of majority charge carriers. For that reason I am going to adding more amount of impurity at emitter. So because of that your emitter is doped heavily. So the next point, the reason for this one is, see this. So emitter is doped heavily to maintain large number of majority charge carriers. Okay, therefore emitter is doped heavily. Emitter is, I do one thing. See, so majority charge carriers. So to support this, that means to maintain large number of majority charge carriers, emitter is doping heavily. So to support it, so therefore emitter is doped heavily to maintain more number of majority charge carriers. More number of majority charge carriers. Majority carriers. Okay, so to maintain more number of majority carriers, emitter is doped heavily. Okay, so far we got why emitter is doped heavily. So we are clear about this. To maintain more number of majority charge carriers, emitter is doped heavily. It's okay. Now, if you observe the width of the emitter is, it is a moderate in size. Now I am going to that. Next point. See, let us, I am taking three things, three boxes here I am taking. One is a small box, that means a small region. Another one is a moderate level, moderate. Another one is a large region. Let us assume these are the semiconductors. Now I want to add some impurity. Let us assume this is the amount of impurity we are going to be adding to this. This is the amount of impurity I am going to adding into this, because your emitter has to be doped heavily. That's why I am adding this one to this. Once we add this one into this, there is a chance of overflow. That's why emitter width is not taking small in size. That's why this is not supported. If I add the same amount of impurity here, these are the impurity charge carriers. So these are the impurity atoms. Now every impurity atom provide one charge carrier to you. And if you add this one to this, so this is very large amount, large size, high size. That's why this is the region. Now if you select a region like this, for example, I am taking a unit space, the same amount of space here also I am going to take. In this region only 4 number of charge carriers are available, but in this region more number of charge carriers are available. So by taking the moderate size of emitter, we can maintain high density of majority charge carriers. If I take the emitter region large in size, density of charge carriers is low. Therefore, to maintain high density of charge carriers, emitter size is moderate in size. Emitter is moderate in size. Emitter is moderate in size. That's it. So far we are clear about complete emitter, why it is doped heavily and why its size is moderate. We are clear about these two things. Okay. So we are clear about emitter so far. This is about your emitter. Is it clear, sir? Any doubts? This is about your emitter. So next session we go and discuss about the base and collector, why they are constructed like that, what is the reason behind that, and after that operation of the transistor. Okay, next. Now I am thanking to one and all for spending your valuable time with me. Valuable time with us. Don't forget to use my code VROW10 during subscription. Okay, and please click on this bell icon to get the notifications. Don't forget to subscribe us. Please give your valuable comments on YouTube to strengthen ourselves and to provide a better quality data to the upcoming batches. Okay, and please join our Telegram groups to get the latest updates on our upcoming videos. Okay, so now, so students, is there any, if you have any doubts, please give your doubts on WhatsApp, on YouTube. I will clarify the doubts. Please, any doubts? Please, any doubts? My dear students, if you have any doubts, please post your doubts in YouTube. I will clarify those. It's okay. Now, thank you very much. So next session we go and complete the remaining things. Once again, I am welcoming all to this beautiful online learning platform, Unacademy. Thank you very much.